Hello, this is the 12th topic of this course. The topic title is Financing a Company's Financial Needs. So, in this topic, you will learn about financial instruments that can be used to provide the necessary cash for a construction company's operation. So, you will also learn to compare debt instruments with different conditions and how loan provisions and closing costs can increase the effective interest rate on a loan or line of credit. So, an understanding of these principles helps you to reduce borrowing costs and determine the best way to provide the cash needed to operate a construction company. Success in obtaining financing for a company can allow the company to take on additional projects, whereas failure to obtain a financial can be harmful for the company's condition. Uh, Therefore, the rationale for this topic is this topic actually follows the progress payment topic, which was topic 11. So, in progress payments, it is determined that the contractor needs funds, which are finances, to run the project on periodic basis, and these funds fluctuate. So, how can these meet the funding needs is addressed in this topic. So, there are many sources of project financing. So, for example, companies need capital to finance the construction work. Capital can be obtained through equity financing, the sale of assets, or debt financing. So, we will talk about these equity financing and the debt financing in this topic later on. So, in equity financing, existing owners provide cash, or additional owners invest in the company. Alternatively, surplus assets can be sold to generate the cash. So on the other hand, debt financing is another option. It can be helped through trade financing using subcontractors or suppliers or obtaining loans. So therefore, you can see that there are many different ways of getting the finances. Uh, um, when we talk about the loans can be short-term loans, long-term loans, or there are some special kinds of loans. These are called as the line of credit. Uh, Debt financing also includes leases and credit cards. So here you can see that some of the ideas you have already learned in your engineering economy course in your I think year 2 or year 1, probably depending on your course. So we will repeat some of the things which you have learned in your engineering economy course. So one of those things is the interest rate, and the interest is of two types: simple interest and the compound interest. So the simple interest is calculated by this formula, which is the interest amount. The amount of interest is equal to the principal amount, that is the amount of loan, for example, which you have taken or which you have given, times the interest rate. That can be interest rate per year, per month, whatever. That is the whatever the period which you have chosen, and the number of periods so for which the loan has been taken. So if the loan has been taken at say 12% per year and for 5 years, so n will be 5 and then I will be 12% that will be used. So this we can see with the help of one example. So determine the interest due on $100,000 short-term loan with the term of 245 days and a simple interest rate of 10%. So in this case, the interest rate given is 10%. Actually, it has not been mentioned here that whether this 10% interest is for 1 year or for per month, but we will assume that this 10% is 10% is for a year, because otherwise if you assume 10% per day or 10% per month, that will be very unrealistic actually. So interest rate is 10% per year, and then for simplification purposes, so we can convert this 10% interest rate into 10% divided by the number of days in a year divided by 365. So that will be the daily interest rate. So if we and then it is a simple interest rate. Okay, so so in this formula, then P will be $100,000, I will be then 10% divided by 365, and N will be the 245 days. So maybe we can solve this by this approach. So $100,000 is the interest, is the principal amount. 10% is the interest rate. So we can divide it by 365 and multiply by 245, or alternatively, of course, as it can be seen that 10% was for the whole year. So divide by 365 and then 200 multiply by 245. So that means it will be for 245 days. So it means that for 245 days, $6,712.33 was accumulated as the amount of interest. So it means that after 245 days, if the loan is returned, so then principal amount plus the interest have to be returned. Okay. Next example, the other type of loan is the compound interest. So here is a short comment on the simple interest rate. So simple interest rates actually ignores the effect of compounding interest. So therefore, simple interest is seldom used for loans with terms longer than 1 year. So this is just a as a practical recommendation or approach which is used, that simple interest rate is normally for 1 year. So after the simple interest, we can talk about the compound interest. So in the compound interest, we can use the interest rate based on the number of compounding periods. So in this case, we use the formula interest rate is equal to the R over C, where R is the nominal interest rate per year or annual percentage rate. So its another name is also annual percentage rate or APR, and where C is the number of compounding periods in a year. So we use this type of interest rate in the formulation for the compound interest. So how we can use it? So let's see it with the help of the example. So determine the quarterly interest rate for a loan that charges an annual percentage rate of 12%. So the loan charges interest quarterly. So it means that although the annual percentage rate is 12%, so it is not like after 1 year it will be charged as 12%, because the loan is actually charged after every third month or after every quarter. So in this case, the quarterly interest rate will be 12% divided by the number of quarters in a year, which are 4. So for example, in this case, it will be 3%. So it means that the 3% interest will be paid in each quarter. Okay, so this is what we have learned up to now. But of course, this is not the only situation which is there in the compound interest. So compound interest is more complex than the simple interest. So that we can see with the help of this example number 3. Now we will solve a number of more examples over here. Uh, Determine the monthly interest rate for a loan that charges an annual percentage rate of 12%. So the loan charges interest monthly. So in this case, instead of quarterly, the loan is being charged monthly. So 12% is the annual nominal interest rate. So 12% divided by the number of months, which is 1% month, is charged each month. So this is one example. Some more examples for the compound interest rate. So in this case, determine the interest rate for a billing period with the 28 days for a loan that charges an annual percentage rate of 12%. So in this case, 12% per year. So what we can do is, in this case, 12% per year interest rate can be divided by 365. That will be the daily interest rate, and then it will be multiplied by the number of days. So because the billing period is 28 days, so which is not exactly 1 month. Okay, so in this case the interest rate will be 0.92% interest rate per 28 days or per billing period, whatever the thing which we want to say about it. Okay, so we will gradually learn about more concept about this compound interest. So this is another concept which is called as the yield or annual percentage yield. This is because in this case for the compound interest rate, since the interest is charged like on monthly or quarterly basis, and the interest is actually compounded, which means that when the interest is calculated for the next period, the amount of interest is calculated on the original amount plus the amount of interest which was obtained in the previous period. So therefore the effective interest rate would be much higher than the annual percentage yield, annual percentage rate. So for this we use a term which is called as the annual percentage yield. In other engineering economy books, we can also use this term as the effective interest rate, effective annual interest rate. So effective annual interest rate or annual percentage yield are both the same things. So this can be determined by this formula. Okay, so annual percentage yield is represented by IA, and then in the brackets you have 1 plus R over C, and then power is C, and then minus 1, so which is the annual yield. IA is the annual yield, R is the nominal interest rate or the annual percentage rate, and the C are the number of compounding periods. So for example, if the compounding is done quarterly, so C will be 4. If the compounding is done monthly, C will be 12, or like that. So let's see it with the help of an example. Okay, so determine the annual percentage yield for a loan that charges an annual percentage rate of 12% compounded quarterly. So of course 12% compounded quarterly means 12 divided by 4, 3% per month. So 3% per month means how many percentage effective interest rate or yield in per year. So that we can determine by the previous formula. So 1 plus 0.12 divided by 4 power 4 C R over C power C minus 1. So it will be 12.55% of 0.1255, which means 12.55%. So due to the compounding, that means annual percentage yield of 12% is equivalent to 12.5%, 55% annually. Okay, so this is the effective interest rate per year. We can see one more example, example 6. Determine the annual percentage yield for a loan that charges an annual percentage rate of 12% and charges interest monthly. Okay, so we will look at it in the next video clip.